All right, so let's do section 9.2, page 454, number 25, which reads, identify the indeterminate form and evaluate the limit using L'Hopital's rule. So for number 25, we have the limit as x goes to 0 from the positive side of 1 plus 1 over x, all raised to the x. And we've been talking about a number of different ways to evaluate limits, and one of the first things to do is to make a graph. So when I put this into my calculator, I get something that looks like that, and something that looks like that. So as we approach x equals 0, we have a discontinuity for this limit, and that's probably why we're only interested in approaching the limit from the positive side, or the right-handed limit. So the second thing that we do when we're trying to evaluate limits is to substitute in. So let's do that and see what we get. So we're going to get 1 plus 1 over 0 to the 0. And what's 1 over 0 going to be? Infinity. And what's infinity plus 1 going to be? Still going to be infinity. So I'm going to have infinity to the 0. And this is going to be the indeterminate form, and that was the first task for us, was to identify this indeterminate form. And remember that indeterminate forms are meaningless answers, and you can't stop when you have an indeterminate form. You haven't solved the problem. Now, unfortunately, this indeterminate form is not one that lends itself to L'Hopital's rule, so we're going to have to be creative. And just as in the last problem, number 21, where we had something raised to a power, we try using the method of taking the limit of the natural log of the function, and then at the end of the problem, raising e to whatever the answer of that limit was. So let's just go over here and review for a minute what we mean by that. So if we're talking about the limit as x goes to a, the method we want to apply is first to find the limit as x goes to a of the natural log of f of x. And presumably that's going to be equal to L, which is going to be a reasonable, meaningful answer. However, what I'm really trying to find is the limit as x goes to a of f of x. So I need to employ the trick that natural log and e are inverse operators. So taking the limit as x goes to a of f of x is the same thing as taking the limit as x goes to a of e to the natural log of f of x, because the e and the natural log will undo each other. They're inverse operators. So this is going to be equal to e to the limit as x goes to a of the natural log of f of x, but we've already solved for that, and it's equal to L. So this is going to give me e to the L. So the next step in solving a problem like this is to take a side trip and determine what this limit is equal to. So I'm going to change pen colors here, but I also need to set my thickness, and I'm going to find the limit as x goes to 0 from the positive side of the natural log of 1 plus 1 over x to the x. And I want to take advantage of the property of natural logs, which lets me take this exponent and bring it down in front. So I'm still going to have the limit as x goes to 0 from the positive side, and I'm going to have x times the natural log of 1 plus 1 over x. Now I have a problem here, because in order to be able to apply L'Hopital's rule, I need to have a numerator and a denominator, and I don't have that right now. So we're going to need to get a little creative, and basically what we're going to do is take this x and move it into the denominator. So I'm still going to have my limit as x goes to 0 from the positive side, and I'm going to have the natural log of 1 plus 1 over x. But to move this x to the denominator, I make it 1 over x. And now I'm going to substitute in and see what I get. So I get the natural log of 1 plus 1 over 0 divided by 1 over 0. And again, what's 1 over 0? Infinity. So I'm basically going to have the natural log of infinity over infinity. So I've got infinity over infinity. that is a indeterminate form that I can apply L'Hopital's rule to. So we are in good shape here, and we can keep going. So I've got my limit as x goes to 0 from the positive side of the natural log of 1 plus 1 over x all over 1 over x. Now remember, when we apply L'Hopital's rule, we're going to take the derivative of the numerator and leave it in the numerator. And we're going to take the derivative of the denominator and we're going to leave it in the denominator. We're not going to be applying the quotient rule here. So I still have a limit as x goes to 0 from the positive side. And we can start with the numerator here. And when we take the derivative of a natural log, we start by writing 1 over whatever I'm taking the natural log of. So I've got 1 over 1 plus 1 over x. And then I have to multiply that by the derivative of what I was taking the natural log of. And what is that going to be? Well, it should be negative 1 over x squared. And if you don't know how to do that, you need to go back and review your rules for taking derivatives. And then I'm going to take the derivative of the denominator, and what do I get for the derivative of 1 over x? Well, again, I'm going to have negative 1 over x squared. And I want to do some simplification and some algebra here. So the first thing I'm going to do is realize that I can cancel those two things, and that I'm going to have the limit as x goes to 0 from the positive side of 1 over 1 plus 1 over x. And I would feel better doing a little algebra. So I'm going to find a common denominator in my denominator. So I'm going to have 1 over x plus 1 over x. And then I'm going to do some further simplification here by taking the denominator of my denominator and making it a numerator. And it's going to be over x plus 1. And now I'm going to substitute in again. So I'm going to get 0 over 0 plus 1, or 0 over 1, which is equal to 0. And that's an acceptable answer for a limit. It's not the answer to the problem that we're solving, but it is an acceptable answer for a limit. And at this point, you have to remember that all you've done is found the solution to your side trip. You haven't found the solution to the real limit yet. So let's do that. I'm going to change back to purple, but I need to fix my thickness. And what I really want to find is the limit as x goes to 0 from the positive side of 1 plus 1 over x to the x. And I'm finding that by taking the limit as x goes to 0 from the positive side of e to the natural log of 1 plus 1 over x all to the x. And realizing that this is e to the limit as x goes to 0 from the positive side of the natural log of 1 plus 1 over x to the x, but I've already figured out what that limit is. That was my side trip. So this is going to be e to the 0 because the answer to that limit was 0. And what's e to the 0 going to be? 1. So that's what my answer is.